full screen preview. All right. Good morning, everyone. This is March 30th, 2020. This is not A3 pre-calculus, though. This is A1 Algebra 2 CP, not A3 pre-calculus. So let's make sure we're actually under the right thing here. All right, fantastic. So this is March 30th. This is Algebra 2 CP. Today we are going to start by going over one of the questions, particularly number 3 from the distance learning assignment that I gave you last class. I think that's a great problem to just wrap up that idea on those advanced radical functions, the ones that involve distributing twice. And then after that, I am going to introduce to you today some applications of radical functions. The applications are really just working with formulas that just so happen to have radicals in them. We're going to talk a lot more about them when we get to them, though. So first, let's actually make sure we go over one of those problems. A little reminder, because I see some people just coming in now, make sure that you please fill out the attendance form on Google Classroom. It's the same one that we've been using. There's no sense in creating a new one. And make sure that you have the assignment open from the distance learning day 3. We are going to go over problem number 3 just at the start of class. Make sure that your microphones are muted, which I believe they all are, and your webcams are disabled, which again, I believe just by glancing here that they all are. If you have a question at any point, again, feel free to interrupt me. But right now, let's go ahead and get started with some algebra. So first, let's go ahead and just review the problems that we did the other day. So I would like to start out by solving one of those complicated radical problems for you again. I think number 3 is a great problem from the previous homework assignment because it has one real solution and one extraneous solution. I guess that's a spoiler, but it says in the answers anyway. So let's go ahead and see if we can solve this equation. We have the square root of 10 minus 2x is equal to 2 plus the square root of 2x minus 6. Okay? So if I take a look at a problem like that, one thing that immediately comes to mind to indicate that this is an advanced level problem, or what I would call an advanced level problem, is that there's a constant stuck onto the radical on the right side. It's impossible to isolate both radicals at the same time because of this annoying plus 2. It's either going to be over here, or if you moved it over to the other side, it's going to be stuck on this one now. So we kind of just got to deal with it and roll with the punches. What I'm going to do is I'm going to square both sides once to eliminate the leftmost radical. Then I'm going to have to distribute on that right side with the radical. And then combine like terms, simplify again, and distribute again. So that's really what I'm going to be gearing up to do. So let's do it. I'm going to square first on both sides. We got 10 minus 2x, the square root of that, is equal to, square, 2 plus the square root of 2x minus 6. And we're going to square this side as well. On the left side, the square and square root cancel out. I'm left with just 10 minus 2x. But on the right side, there's a lot more work to do because we have to take that thing and multiply it by itself. So I now have to do 2 plus the square root of 2x minus 6 times itself, 2 plus the square root of 2x minus 6. Okay? Now let's do a little first outer and a last. I still have my 10 minus 2x. I now have 2 times 2 is 4. 2 times the square root of 2x minus 6 is exactly that. Just like if you had 2 times x, you would write 2x. Here I have now 2 square roots of 2x minus 6. Notice the same exact thing happens on the inside too. 2 times the square root of 2x minus 6 is another 2 times the square root of 2x minus 6. And last but most certainly not least, the square root of 2x minus 6 times the square root of 2x minus 6 is 2x minus 6. Hopefully that makes a lot of sense to everybody. Because again, the square root of something times itself is just whatever is under the radical. Now I can go ahead and combine like terms and clean up that right side. I have 10 minus 2x still on the left, not changing that. Notice I have a 4 and I have a negative 6, so altogether that makes negative 2. I have a 2x that doesn't really combine with anything else, so I'm just going to say plus 2x. And now I have 2 of these square roots and then 2 more of these square roots. So in total, that would make 4 of them. 4 square roots of 2x minus 6. Just like that. Alrighty. Now, again, a very common mistake that I want to point out. Please, please, please watch out when you do this. It is very easy to do. Something that's very easy to do is to combine this 4 plus 2 here. A lot of students will do that and just say, oh, this is now 6 square roots of 2x minus 6. But it's just like if you had 4 plus 2x. You wouldn't combine that to make 6x. That doesn't make any sense. So just be very mindful of that. Now I'm just going to isolate this radical. I'm going to move the 2 over to here by adding 2. I'm also going to subtract the 2x over to the side. Subtract 2x. I have 12 minus 4x is now equal to 4 times the square root of 2x minus 6. Now remember what we said last class. Last class I indicated to you that if we can divide evenly by that coefficient right there, it is hugely beneficial to do so because it just ensures that you're now going to be working with smaller values. So I'm going to do that in this case because you notice that everything is divisible by 4. So the fact that everything is divisible by 4, and by everything I mean this term here and this term here can divide evenly, I'm going to go ahead and do that. I'm going to divide both sides by 4. Now, do you have to divide both sides by 4? No, you can still get the right answer by leaving that 4 in there and distributing, but you're just going to be working with larger values, and you're going to have to take out a GCF when it comes way down to the end. So it just saves you a lot of work. Here I'm going to get 3 minus x is equal to, now the 4's cancel out, I get the square root of 2x minus 6. Hopefully no questions, but again, if you do have one, feel free to interrupt. Again, this is problem number 3 from the assignment that was due today, the distance learning assignment. I think it's great to go over. It's good review. Now, this should be a somewhat familiar problem because now this is a typical single radical problem where we're just going to square both sides, distribute a little bit, and solve. So here the square root and square cancels out. On the right side, I get 2x minus 6. On the left, I now have 3 minus x squared. We have to take that and multiply it by itself. Distributing, I'm going to get 9 minus 3x minus another 3x makes minus 6x, and then plus x squared is equal to 2x minus 6. Okay. Once again, when you see that x squared show up, that's an immediate indication that you need to factor. You have to. You got to factor. But before you factor, you have to make sure you set equal to 0. So that's exactly what we're going to do. I'm going to subtract 2x over to here. I'm going to add 6 over to here. I'm also going to rearrange everything so it's in a familiar order again. I'm going to make x squared minus 8x plus 15 is equal to 0. And now we can factor this by saying we need x and x. Since we're multiplying to a positive at the end, that means our signs have to be the same. But since we're adding to a negative, it makes sense to make them both negative. And then what numbers are going to multiply to 15 and somehow combine to be this negative 8 is negative 5 and negative 3. Okay, that gives us two potential solutions of x equals 5 and x equals 3. Again, I say potential solutions because we do have to make sure we check them, which I'm going to do very quickly for you now. Going way back up to the top, I'm going to check first the x equals 5. Is it true that the square root of 10 minus 2 times 5 is equal to 2 plus the square root of 2 times 5 minus 6? Is that true? Let's find out. 10 minus 10 is 0, so the square root of 0 is 0. Is that true that that's equal to 2 plus the square root of 4? Ugh. Oh, gosh. Oh, not even close, right? No way. No way. Definitely, definitely, definitely extraneous. Okay. But again, hope still remains. Let's check. When x is equal to 3. Is it true, going all the way back up to the top, that the square root of 10 minus 2 times 3 is equal to 2 plus the square root of 2 times 3 minus 6? Is that true? Let's find out. So here I get 10 minus 2 times 3, that's the square root of 4. Is that equal to 2 plus the square root of 0? Absolutely it is, right? Because the square root of 4 is 2, so we're happy. So this problem does have one solution, which is x is equal to 3. All right. Trying to get that all in the camera at once. Does anybody have any questions, comments, or concerns about that? I'll give you a couple seconds to digest that. Seems like we're all good. Seems like we're all happy. Okay, fantastic. So now, oh, sorry, go ahead.
Can you show another example after?
Of this?
Yeah.
If I have time. I want to make sure we get into word problems today. If
Okay.
I don't have time, though, I will certainly do it out and post it on Classroom. Is that fair?
Okay.
All right.
Sounds good.
Yeah, cool. Thanks, Luke. I appreciate that. All right, let's go into some word problems. All right. I know, again, whenever I say word problems, everybody always gets like anxiety and all freaked out. No reason to freak out. No reason to worry. Word problems in radical functions are really just dealing with equations that have square roots in them, because now you know how to work for them, or now you know how to work with them. But instead of solving for information that you may be used to solving for, we're now going to solve for different parts of that equation. What do I mean by that? Well, let's take a look. Here's some applications of radical equations. Okay? One great problem that has one great thing that we've worked with, one great equation that we've worked with that has a radical in it is our good old friend, you probably already know what I'm going to say, the quadratic formula. Oh yeah, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I don't care if this is being recorded, I'll sing it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You remember that, right? Of course you do. Well, if you notice, that equation does have a square root in it. And what we're used to solving for is we're used to solving for x, right? You're used to saying, well, a is this, b is this, c is this, plug them all in, and let's solve for x. However, we can certainly take something like this, and now that we know how to work with radicals, what if we solve for a? Or what if we solve for c? We could do that, right? No problem. So consider this problem. Ready? Okay. Solve for c in the partially completed quadratic formula below. Okay, so instead of solving for what x equals, let's solve for what c is equal to. If I said, what if 9 is equal to 5 minus the square root of 5 squared minus 4 times 1 times c all over 2 times 1. The reason why, again, it's partially completed is because this is just one of the possibilities with the minus. If you do the plus or minus, it turns into two separate problems. That's not something we'll have to worry about in the context of Algebra 2 CP. So if I have an equation like that, I can certainly solve for c. There's no reason why I can't. The first thing I'd probably want to do is clean up a lot of these calculations here. Just giving me 9 is equal to 5 minus the square root of 25 minus 4c all over 2. Right? That makes a lot of sense to me. Now, in order to get c by itself, because that's the ultimate goal, I want to say c equals. Right now, it's all being divided by 2, so let's make sure we get rid of that 2. I'm going to multiply by 2 on both sides. That gives me 18 is equal to 5 minus the square root of 25 minus 4c. Right? Now we can isolate the radical like we're used to doing. Let's subtract 5 over to the other side. I get 13 is equal to the opposite of the square root of 25 minus 4c. Now here, you can, if you so desire, divide by this negative 1. It's really not going to matter because when you square both sides, this, a negative squared becomes a positive anyway. So if you squared this side, you're going to notice that the negative is really just going to disappear. If you divided by negative 1 and moved it over to the 13 and made that negative 13, negative 13 squared is still a positive value, so it really doesn't particularly matter. We're just going to square it as is, but I just want to make sure I pointed that out to you. I get 169, that's 13 squared, is equal to the square root and square cancel out, 25 minus 4c. And now this is just good old Algebra 1, where I can go ahead and solve for c. Let's subtract 25 from both sides. I can get 169 minus 25, so that's 144, is equal to the opposite of 4c. I can divide by negative 4, and lastly, I get c is equal to negative 36. Okay? So the actual value that would make this equation work out is negative 36 for c. All right? with applications, I know I really emphasized it with actual equations. With applications, I am not going to require you to check for extraneous solutions. And the reason is because these are applications, you are guaranteed that these answers will actually work out because they're tied to real world things. They're tied to mathematical formulas that have been proven. It's not like you're taking this random equation that was just made up by somebody. You're taking the quadratic formula, which is a proven mathematical thing, and just finding the missing value. So with applications, in short, you do not have to. So I'm just going to say do not have to check for extraneous solutions. Though you certainly can. You certainly can if you wanted to. If you wanted to just double check and make sure, you could certainly take this negative 36, plug it in for C, and that should all work out to equal 9. That's a great way to check your answers. Okay, it's a great way to check your answers. Any questions on that? I want to do one more word problem, and then that should probably be it for the day. Another great formula that you've used in math. Not just the quadratic formula. There's another one. Going back to last year. You'll see it in just a minute. Any other questions? Pretty clear, hopefully, makes sense. Excellent. All right, let's take a look at just one more. Let's get a fresh piece of graph paper here. Fresh piece of graph paper. All right, here we go. How about, like I said, there's one more that uses a great formula from last year. A great formula from last year that you may remember has a radical in it is something that's called, oh yeah, the distance formula from geometry, right? You remember that the distance formula is how you find the distance between 2 points. I'm not going to test you on what the distance formula is or how to prove the distance formula, but it is still an equation that has a square root in it, so you should still be able to work with it, just like any old equation that has a square root. So the distance formula, and by the way, I will always give you the distance formula. I'm not asking you to memorize the distance formula. That's not in the context of this class. That's outside of the scope of this. I'm going to say that the distance is the square root, if you're given 2 points, hopefully you remember it, x2 minus x1 squared, or maybe it's coming back to you, plus y2 minus y1 squared. Don't worry if you're thinking to yourself, oh, I hate geometry. It's okay, we're not doing any real geometry per se. It's really just applying and using the formula. All right, so what if I told you that the distance between 2 points is the square root of 26 units. Okay, radical 26 units. And your points are -2, 2 and x, 1. And could you find values of x that satisfy this equation? If you notice, again, this is a little bit of a twist on problems that you're used to, right? You're used to getting the points and just plugging them in to get the distance. But certainly now that we know how to work with radicals, there's nothing stopping us from solving for one of the points, for example. So let's go ahead and just plug into my distance formula. Don't get freaked out by the fact that the distance is a square root. You're going to see that that's really not going to make much of a difference in just a minute. So I would say since my distance is the square root of 26, let's plug that in for D. The square root of 26 is equal to, remember when we have these coordinates, I have my x2, my x1, my y2, my y1. It actually doesn't matter which one you call x2 and y2 or x1 and y1, as long as you're consistent and don't mix them up. Like you could call this x2, y2 and this x1, y1 if you really wanted to. As long as you don't cross over, then it should work out just fine. So I have the square root of 26 is equal to the square root of x2 minus x1, so that's going to be x, because we don't know what that x2 is. That's what we're trying to solve for. Minus the opposite of 2 squared, plus y2 minus y1, 1 minus 2 squared. Does everybody see how we set that up? Now it's just a matter of getting x by itself. So you didn't really need any geometry in order to do that. I now am going to see this big old radical over here. big old radical. We want to get rid of that thing. That is an ugly radical. We want to get rid of it. Let's square both sides right away. Squaring both sides right away will get rid of that radical. And actually, good for us. Like I said, don't worry about this square root over here, because squaring both sides gets rid of that one too. So I now have 26 is equal to x plus 2 squared, just simplifying that minus negative 2. I have plus 1 minus 2 is negative 1 squared. All right, let's do a little, I mean, your Algebra 2 instincts should just be kicking in as far as what do you think you need to do next? Well, let's expand that binomial, and obviously negative 1 squared is positive 1. So I get 26 is equal to, in order to square x plus 2, make sure you multiply it by itself, and then plus an additional 1 on the outside. So you get 26 is equal to, we get x squared plus 4x plus 4, after doing a little first, outer, inner, last there. And then my plus 1 stuck at the end. Now, again, just like before, I see x squared. That's a prime time indication that I need to factor. So in order to factor, let's set equal to 0. Subtract the 26 over to this side. I get 0 is equal to x squared plus 4x. And then 4 plus 1 is 5. 5 minus 26 is minus 21. We can now factor that. Since we're multiplying to a negative, we need a 1 positive and 1 negative, and the values that are going to make that work is plus 7 and minus 3. And so I get two solutions here of x equals negative 7 or x equals 3. What that means is it could really be both of them. X could equal negative 7 or x could equal 3, because you could create a line that's this far away from this point. If x is negative 7, that would just mean you kind of draw it this way, right? Think of a coordinate plane. It looks like this. That would mean you just drew it this way, versus 3 means you drew it this way, right? You drew it to the right. It's still just drawing a line that has a distance of the square root of 26. Again, if you so desired, you could take those values, plug them in to check for extraneous solutions, and it should all work out. But does anybody have a question as to how we were able to take something like the distance formula and solve for a value that you're not used to solving for? Any questions, comments on that? All right, excellent, fantastic. I'm happy to hear it. That should mean it's making sense, I hope, right? If that means that we're engaged and it's making sense, I love to hear it. So, since we have just about 6 minutes to go, I will do another problem like Luke suggested, going over that other double radical square root problem. I have no problem doing that. One thing I want to mention is that you do have a homework assignment. It is on Classroom. It's kind of split up over 2 days. It's 10 word problems. I'm asking you to please complete 5 of them in preparation for next class, which is Wednesday, April 1st. And I'm asking you to complete the other 5 in preparation for Friday, which is April 3rd. One thing that I want to mention is that on that Friday, I'll be happy to do any sort of review. Essentially, that Friday is going to be a big review class where I'm going to go over some equations, go over some word problems, and make sure that we're all set. I am also going to assign a progress assessment on that Friday. What is that going to look like? Great question. It's going to really be just this document that you all receive on Classroom. It's going to have a couple questions on it, a couple equations, and a couple word problems. What I'm going to ask is that you solve it. You take a picture of your work and you submit that image on Google Classroom. You know how you can drop assignments on Google Classroom? I'm asking that that's exactly how that gets done. I'll talk about that a lot more next class and Friday's class, but I am going to assign that on Friday to have that due next Tuesday. So that's plenty of time. I don't think that's unreasonable by any stretch to work on that progress assessment at home by yourself. One thing that I want to mention is again, I'm asking you to take a picture of your own work to get it done. There will eventually be a summative assessment on all of this stuff. At this time, I don't know what that summative is going to look like, whether it's going to be delivered to you via Google Forms, or it's going to be just another instance of I'm asking you to do work and take a picture. I don't know the answer to that yet. Or if it's going to be some timed thing where it's going to be like you enter into this program, it times you for 45 minutes, and then you at the end of the 45 minutes you submit. I really don't know. Yeah, Luke, I'll do that for you. He said, could you post a checklist of the things we have to do? Yeah, sure. I can do that in our Classroom to clarify for you. But we'll find out what that's going to look like, and I'll relay that information to you soon. But again, since that summative assessment is something that you are going to do, make sure that you get it done. Make sure that you get the progress assessment done on your own and work hard and practice, okay? Julia just asked you, can I post the notes on Classroom as well? I do always upload these video lessons online, and I post the links on Classroom, so just make sure to check that out, and they should be all there, all right? All right, fantastic. So let's spend our last 5 minutes doing that other problem together. Again, by next class, all I'm asking you to complete is the first 5 word problems on the word problems assignment that I just posted. All right, so let's do that other double radical problem together. We'll do it down here in this space. Okay, the other one that I assigned you, this was number 2 from the actual assignment, was -2 plus the square root of 5x plus 1 is equal to the square root of 3x minus 5. Okay? Again, we know it's one of these double radical problems because you can't isolate both at the same time. I'm just going to go through it a little fast because I've kind of already explained one of these today, but that's totally fine. I got -2 plus the square root of 5x plus 1 times itself. And that's equal to the square and square root go away, 3x minus 5. Little first, outer, and last, I get 4 minus 4 square roots of 5x plus 1. That comes from -2, and then another -2 on the inside, plus 5x plus 1. Square root of 5x plus 1 times itself. Combined like terms, 4 plus 1 is 5, plus 5x doesn't combine with anything else. Minus 4 times the square root of 5x plus 1 is equal to 3x minus 5. I'm going to, let's see, move this stuff over here. So let's subtract 5 from both sides. Let's subtract 5x from both sides. That gives us -4 is equal to the square root of 5x plus 1 is equal to, let's see, 3x minus 5x is -2x. And then I get -10. All right. Something that you can do here because, oh, sorry, I said -4 equals. Jeepers. No. -4 times. Yikes, I just caught that mistake. Something you can do here, since -2 and -10 cannot be divided by -4 evenly, but you can divide by 2 evenly, right? That'll help simplify things a little bit. So I can get -2 times the square root of 5x plus 1 equals -1x minus 5. Again, I would love to divide by the entirety of -4, but I also don't want to deal with fractions. So this is a pretty good compromise. I can now square both sides. I get -2 times -2 is +4 times 5x plus 1 should be equal to the opposite of x minus 5 squared. We just have to multiply that by itself. So I get, distribute here, 20x plus 4 is equal to x squared plus 10x plus 25. Yes, I'll continue this problem just up in this little space over here. I definitely need to combine like terms and factor. So subtracting the 20x and subtracting the 4 over to the other side, you get x squared minus 10x plus 21 is equal to 0. And now we can factor that down to x minus 7 times x minus 3 is equal to 0. Gives me 2 potential solutions of x equals 7 and x equals 3. I am going to entrust that you know how to check for extraneous solutions at this point, just because we're running out of time. And if you check, you would actually find that both of those solutions are valid. So this problem would have 2 solutions. All right? So that's pretty much that. Hopefully nobody has any other questions. If you do, though, feel free to ask. If you haven't filled out the attendance in Google Classroom, please make sure you do that. There's a little attendance form. Make sure you get that done. All right? But other than that, that's all I got for you guys today. Again, I'm asking you to complete the 5 word problems, the first 5, for the start of next class. All right? And if you have any other questions, even in the slightest, you can feel free to reach out if you ever need to. Okay? Thank you again. And I hope you have a fantastic rest of your blue day today. See you later.